Well, hello everyone. This is the first of a series of podcasts I'm doing with Geolytix. My name's Ed Parsons. I'm a digital geographer, geospatial consultant, interested in the business of using geography. And I'm here with Blair, and we're going to talk initially about the impact of AI on Geolytix's business, but the wider industry as well. And we're just going to have a conversation, see where that takes us. And we'll dig into more detail in future podcasts about your business and how AI is going to impact it. But to start off, for those people not familiar with Geolytix, who are you? What do you do?
Yep. Okay, so Geolytix is a very simple business. We help people decide where to put things. And those things are big things like shops, restaurants, banks, and also small things like terminals or drop boxes to pick things up. So we help people intervene in the physical world, and it's nearly all B2C customers. So super big retailers, Tesco, KFC, people like that. People are deciding where to put things, and we help them.
So this is almost an invisible infrastructure that's there. It's operating behind the scenes all the time. We're, as members of the general public, we're not aware that what's going on.
No, I love explaining to people when I meet them at a dinner party or in a pub, because what we do is so tangible and real, and people don't realise we exist. We're the sort of the hidden hand, like Adam Smith's invisible hand of the market. We're the invisible hand that helps decide whether an M&S pops up next to you or whether your local post office is relocated. These massive decisions, real estate is the single biggest asset class on the planet, and putting the right stuff in the right place is hugely, hugely important.
So let's drill into that then. So how does it work? How are those decisions made? I guess we talk a lot about data-driven businesses. Yep. You must be very much a data-driven business.
We are. I'm slightly hesitant of data-driven. I much prefer data-enhanced, because humans always make decisions. And I don't think you will ever get to 100% data-driven location decision. Just think, if you're going to buy a new house, are you just going to let an algorithm tell you and then deliver the keys to you on the Monday? No, you're not. I don't think anyone will ever buy a house like that. And it's the same with commercial real estate. The decisions are so big and nuanced that there will always be the element of art together with all of the data and the science, et cetera, et cetera. So we are kind of the numbers guys.
Yeah.
We're the people who bring the science to the party. And then the clients, the retailers, they'll go out and sniff the air and kick the tires and is this the sort of place we want our brand? But yeah, we bring the numbers, and people like us we've been here forever, right? People like us have existed as long as retail's existed.
Wow.
It's not been digital.
Okay. I was going to say.
We didn't have, but M&S in, 1890s when they're opening the very first store in Leeds, like someone is going out trying to count and trying to work out, is this place busy? Do the people who shop here look like the right sort of people? Famously, Sam Walton, in the growth of Walmart, he did it by flying an aeroplane because he didn't have digital maps.
Yeah.
So he would get in an aeroplane and fly over the Midwest and look at the towns, and he got very good at understanding street structures and how old does this place look and does this town look affluent, all from his aeroplane.
Incredible.
So he was doing data-driven site research in the 50s, didn't have a computer, obviously. And you go all the way back. So the birth of retail, which, retail becomes formalized in sort of the 1830s, 1840s, part of the Industrial Revolution. Before that, you just have markets.
Yeah.
So actual organized retail comes about, the word shop didn't even exist in English until 1850. So, but when that's all happening and the department stores are growing, that is all done using some form of data. Again, famously in America, department stores were always one day's horse ride apart. That's how they spaced themselves.
Right.
So if you could get on a horse and get from one town to the other, you didn't need another department store. But if it was more than a day's ride, you would put another store. So this sort of the science of organising where stuff goes has always been here.
Yeah, I mean, this is fascinating. As a geographer at heart, a geographer by training, I love the systems that are behind this, and I guess many people listening, watching might think, well, there's an element of gut feel to this. That's what you perceive it to be. But as you say, in reality, we've always taken this scientific approach. We've always, made decisions based on data, made decisions based on the information that's at hand to us. And clearly in the last, I guess, 20, 30 years, the amount of information we've got has become much richer. Yeah. And can you talk about, where that information has come from before we then, I guess, start to talk about AI? But what sort of information are you using? It's clearly where do people live, but there's more than that.
Yeah. So we in our heads, we kind of split the data into various different categories. So as you say, the first part is data about people, which if you go back to the 80s and 90s was almost entirely census. So in the UK, the first census that was released in digital form was 1981. Before that, it just sat in tables. Couldn't get it in electronic format. But so the census in 81, 91, and then it goes open in 2001. That was the bedrock of when location planning was growing up as a digital, sophisticated discipline. It was all about census data. So that's data about people. And then you have data about places and points. So we think of it as the 3P, people, places, points. And so points is an obvious one. Yep. Where are the shops? Where are the tube stations? Where are the hospitals? Where are the university halls? Points. POI is it's a lovely bit of jargon we all know in this interest, points of interest. So you have data about points. And then you have data about places, which might be a retail street. We're sat here in Old Street. And so there will be a retail place that is City Road South going down where we are. There will be another boundary that is Old Street Roundabout, which will be all of the shopping around there. Then there'll be another boundary for Angel up City. Is it City Road? Yeah, City Road North up to Angel. So you'll have places. You'll have polygons that are defining a place, or it might be an education campus, which contains all the POIs, and then you'll draw a boundary around. So this is a place. So we have points, places, and people, and for many years that's all we had. And we then built models off of that. And we would come up with, okay, if there are 20,000 people within 12-minute drive and there's lots of good POIs and it's in a strong retail place with lots of buzziness, right, let's open a Costa Coffee here. So we'd have all of these rules using these three things. Then in the last 10 years, sort of some new ancillary data sources have emerged. We think of them as exhaust data, which is it's data produced by a process that's not designed to produce data, but it comes out the back of the engine, so why not? Let's use it. Yeah. So that's things like mobile phone trace data. It might be you're familiar with Google search terms off mobile devices. It might be banking data, so we can see all the card taps. It might be mining social media data, so I know geo-tagged Twitter's tweets.
I remember those.
Yeah.
I remember that.
Everyone got very excited about those. or things like Instagram and photographs and sort of like loads of people taking photos here and posting it, therefore it's a tourist area. So all of these new digital data sets have emerged in the last 5 to 10 years, right, and they are increasingly vital. I don't think we build a model that doesn't take advantage of those data sets now.
Now, I guess everyone listening, watching this at home is going to be concerned about, all of this data, how's it used, where's it going to be used? Don't worry, we're going to cover that in later podcasts. Clearly, it's an area of concern. Don't worry, we'll get back to that. But I guess from what you've been saying, this is an area completely in the center of this storm that AI now is presenting. And, one of the ways I think about artificial intelligence is that it is just another form of data analytics, another form of analyzing data. Very powerful, but it is fundamentally driven by the data that powers it. Initially, where do you see AI impacting on your business?
Yeah. So again, I'm very much with you. I think we have to be really careful with language. AI, people will they'll get all excited and say, oh, it's AI. And then you sort of lift the lid up and you go, oh, that's a regression model. Yes. I remember those from 30 years ago in college. Or someone will put a big spin of, oh, it's agentic, vibe coding, blah, blah, blah. And that doesn't really matter.
Well, let's back up a bit. When you say, oh, it's just a regression model, what does that mean for, someone that hasn't done statistics or like most people probably slept through the statistics they did at college, school, wherever. What is a regression model? I think that's really, it's actually quite fundamental.
Yeah. And regression models pop up in all sorts of weird and wonderful places, even when you don't think they're regression models. So if we sort of back up and just think about the various classes of modeling approaches that exist in our business. Regression modeling is one. There's also classification models, there's spatial interaction models, there's similarity models, so whatever. But a regression model, at its simplest, a regression model will take something you're trying to predict, and it might be a continuous variable like sales, or it might be a categorical. It might be, are you going to watch this film or not? So it might be a yes, no, or it might be continuous, or it might be categorical. Well, it doesn't matter. In this instance, let's assume it's a continuous, so it's sales. I am trying to forecast sales for this Costa coffee shop that I have not opened yet, but I've got a site and I know where it is. Right, how much is that Costa coffee shop going to take? At its simplest form, a regression model simply says sales in this Costa coffee shop will equal a number, a constant, £10,000, plus for every person within a kilometre, we'll add £4. So it'll be £4 times the number of people within a kilometre. We got a number. Minus however many other coffee shops there are within 50 metres, because there's too much competition. So if there's 5, minus £100 times 5.
Yeah.
Plus, et cetera, et cetera. So it's a big, long recipe that you put in these ingredients, you multiply them through, you get a number.
Yeah.
Now, there's all sorts of complexity you can add into that, but that is fundamentally a regression equation.
And I think that's really helpful, because from my perspective, I think what you look at in many forms of AI models is fundamentally regression happening in multiple dimensions at the same time. And, every bit of data that you feed in becomes another regression model, another line on that graph.
Or they grow into, you might hear people talk about random forests or decision trees or shade or cart, which they build on regression models. So if you imagine a shade model, a shade tree, so a tree model says, I will start here at the top and I will say, okay, if there are more than 1,000 people go down this branch, if there's less than 1,000 people go down this branch, I will then split again. So I will say, how many other coffee shops are there? 1, 2, 3, 4. So I'll have 4 branches in my tree. And I'll keep doing this all the way down, and I'll have this big dendrogram, this big tree structure. But what's actually happening at each node is a regression model. It's a classification. It finds what is the best way of splitting this sample using a whole set of regression models. So it's actually a whole set of nested regression models. So regression models pop up everywhere.
Yeah. And I guess it's easy, I think, probably for us to kind of conceptualize regression models or multiple regression models operating. And to a certain extent, the regression models, as you said, is something that we've used historically. And we understand them, i.e. they're kind of deterministic. We know that if you put this number in, given a particular equation, we can have an idea of what's coming out the other end. Where it's got much more complicated for us, I think, with machine learning now and particularly generative AI, is because you've got so many variables and the fundamental way the models are built, that deterministic approach breaks down.
Correct.
And now we're talking much more in terms of probability. And can you talk a bit more about that difference between deterministic systems and probabilistic systems, which AI is really about?
Yeah, and it's a big old challenge for the explicability of the model. And again, there's 2 schools of thought. There's a school of thought that just goes, look, it doesn't matter. We all watch telly. I have no idea how a telly works. So it doesn't matter that I can't explain it. But there is another school of thought that goes, hang on a minute, I'm going to make a really big, important decision on this. I need to know what's happening. And I think on that spectrum, very small, inconsequential decisions, you can sacrifice explicability. Yeah. I don't really need to understand why Netflix says, look at this film next. I don't really need to understand why my marketing offer to this person is 10p off eggs and to this person it's 50p off shampoo. I don't really need to, it doesn't matter.
Yeah.
But if I'm going to spend 30 million quid on a new supermarket, I probably want to know why I'm getting a result. So that's one school of thought. There is another school of thought that goes, this is a transition and that people will get comfortable over time. And the proof will be in the pudding, right? It's if it's making good calls, people are going to start trusting it. So the reason all of this complexity emerges is a combination of computational power and the search for ever-increasing accuracy and speed of deployment. So to hand build a regression model, and by hand build, I mean the analyst goes in, examines all the variables, does some data reduction, maybe some PCA or whatever, and they do some combinations and nonlinearity. I'll do this as 1 over log, whatever, does all of that investigation. And you're exploring a variable space that's essentially infinite. And so the skilled analyst will go in and put it all together, bolt it together, take you 4 weeks or whatever, deploy the model. Now, because that variable space is so infinitely large, say you've got 10 variables very quickly, because it all goes to shrieks. So very quickly, you end up with more possible combinations than there are atoms in the universe. So what people have come up with, as computers have got better and better and better, is they can search through that combination space very quickly and very efficiently and can build models that rival the old school hand cranking in terms of accuracy. But in order to do that, they are creating a feature space where they will examine millions and millions and millions of permutations.
And this is what they're calling foundation models.
Yes.
You've got such a vast quantity of data that you have to sort of chop away at that kind of section by section to get some meaning from the
correct. And it becomes impossible to figure out what's going on because you can no longer take a single variable because a variable might be used in 100 different places.
Yeah.
And the analogy we use when we explain it to people is, did you ever play Bagatelle? Where you shoot a bearing ball out and it goes through these pins and it goes down all the different paths. That is very similar to how some of the random forest models work. And each pin is a decision point and the pin might be a variable. And if it goes down that side, it'll go down a completely different branch. And at the bottom, there will be a number. It'll tell you these people are 90% likely to like this offer. These people are 80%. But if you try and backtrace what variables influencing it, you can't, because it's going down a random tree. And if it goes down this branch, so instead of there being 1,000 people, there was 999 people, it goes down a different route and ends up with a very different a very different answer. And that's before you even get to the nonlinearity, because what happens in classic linear regression is you assume all the relationships are linear, which we know is not true. The world is a nonlinear place. So all of a sudden you're saying having lots of people is really good, and having no people is really good, but having this number of people is really bad. And it's like, well, how does that make any sense? But that's what the data's telling you because of a weird quirk of whatever your system is. And we come back to the other curse of geography. We actually solve harder problems than anyone else, I think.
Yeah, I agree. Absolutely.
Because the way people travel across time and space and the way people interact with the physical universe is so damn complicated. I love to tell a story. I ascribe it to different people, but it is a true story where we were sitting with some customer focus groups asking why they choose particular stores. And this one lady explained to us that she didn't shop at her nearest, I think it was TK Maxx. She didn't shop at her nearest one. She went to the second nearest one because her ex-boyfriend worked in the one nearest her.
Yeah.
And she didn't want to see him.
For her, that's a rational decision. But how
do I put that in a model?
Yeah, how would you do that? Okay, so to a certain extent, and I guess, for many of the viewers, listeners, this is quite an abstract conversation. We're talking about complicated models, sometimes difficult to explain, very much dependent on the high quality data. Now, I've got to know Geolytix over the last few months. One of the things that stands out for me about you as a company is you're very much focused on your customers. It's almost a partnership, a very direct partnership. Now, for your customers, how do they view AI? And we've talked, at a kind of a technical level, saying, well, it's made of all of these components as another form of data analytics. It's harder to explain than perhaps what you were doing previously. So what's the conversation with your customers about this?
Yeah. So to sort of bring it back to reality, we have multiple conversations. There has been so much noise about AI ever since GPT and the transformer tech that came out of Google. And people, the lay people, and we sometimes forget that 99% of people don't really get involved in the nuts and bolts of these debates. They just see AI as the LLMs. They just know, I go onto Google Gemini now and it can give me a recipe. Or if they're a bit more clever, they might go, I'm using Claude Bot and I'm vibe coding this thing. Isn't AI amazing? Which is one corner of the world of AI, LLMs. And LLMs are exquisitely good at certain things.
Yeah.
They are astonishingly good at certain things. And I'm going off on a tangent here, but basically all our clients hear all the hype about LLMs. Yeah. They get their boss, what's our AI story, Mr. Numbers Man? What are you doing? And it kind of breaks down in our mind into 2 or 3 strands. There's what I like to think of as just table stakes, BAU, use of AI. Right, everyone is going to use LLMs to assist them. If you're a software developer and you're not using Codex or Claude or whatever, you're just going to get wiped out.
Yeah,
everyone is now using these LLM tools, and also any sphere of your work that involves words, the LLMs are beautiful. So, in terms of geography, I'll give you an example of this. If you ask an LLM, what parts of London have a similar vibe to Camden?
Right. Yeah.
It'll give you a good answer because it's text. There is lots of text out there that says Camden is a buzzy area with lots of coffee shops and a very cool market. There's lots of cool, hippie, grungy people. And that will be written about everywhere. So an LLM is really good at saying, oh, hang on, what's Shoreditch? Looks a bit like Camden. You then say, well, what about Dagenham? And it'll go, Eltham's a bit. So it can, because there's lots of words. So LLMs are very good at doing words. And then another subdomain that is all words is programming. So programming language, the clue's in the word, they're languages. And LLMs are exquisitely good at language.
Yeah.
So they can code and they can create things. What the next step, which has always been there, which is, can AI help us predict the future? Which is what we do. We have to imagine a world that does not now exist and say, what happens in this world? Can predictive power, utility, is AI going to help us with that? And the answer is absolutely. But it's not going to be an LLM that does that.
Right. And I think that's very helpful, because I think naturally we think of AI, at least since ChatGPT, through the lens of large language models, and that's our only kind of perspective. But large language models are just one element of a much bigger space.
Yeah.
And I like that model that you have, which is, it's fundamentally, I think about, you can characterize how easy is it to apply an AI solution against how easy is it to verify that solution. So there are some things it's relatively easy to apply an AI solution and very easy to verify that it's working. So vibe coding is a good example of that, where the syntax of a computer program, well, it either works or it doesn't. You can verify that immediately. So hence vibe coding is a big thing. But there are other aspects where actually it's very difficult or incredibly complex to verify the outputs of an AI, and that's perhaps where you will always need a human in the loop. And I think for your customers, kind of focusing in on them again, that human in the loop, I guess, remains quite an important element to the process.
Yep. And again, if you think, so if we go back to the fundamentals of what we do, someone wants to open 50 new food stores, Tesco Expresses, right? We're going to open a load of new Tesco Expresses. Each one's going to be, I don't know, 2 million capex, whatever it is. They will always do what's called a PIR or a post-investment review, is after they've opened a new store, they'll say, we said it was going to do 52 grand a week. It's doing 52 grand a week, big tick. It's doing 30 grand a week. It's doing 60 grand a week, whatever it is. And as the new modeling approaches wind in, that will be where they get tested, because our models are again, they're a little bit different to an LLM or a generative AI. We're trying to forecast something. It's more like weather forecasting. We're saying, if you perturb the system, this is what's going to happen. And the only way you can test that is by going and opening them. I always joke that people ask me, what R squared do you want on a model? And I'll say, what R squared do you want? Because I can give you whatever R squared you want. But that won't be a powerful model. A powerful model will predict the future reliably. And the only way you can do that is build a model, crank it through. After 6 months go, well, look, we've opened 30. This model was great. This model was rubbish. Human judgment, I know some retailers have a really nice system where each stakeholder will say what they just personally think it's going to do. So it's just a human judgment.
Yeah.
And then, you measure them all up. Was the model better than the human? Which model worked? Which model didn't? Why didn't it work? So that's how you test.
And I think that's really important to hear, that this is, by design, an iterative process. You don't just create a model, deliver it, and then walk away.
No. I mean, we do have. I'm sometimes slightly envious of some of my cousins in other modeling spheres. So things like marketing A/B testing. Show this advert, which gets most clicks.
Yeah.
The feedback loop is instant, and you can be out doing mass testing. Like, we don't get to do that. And the other thing we don't get to do is no one opens a store thinking it's going to be rubbish. So we do not have a random sample of locations. People always open stores where they think they're going to be brilliant. So we have a very weird sampling set where everything has been selected for. So no one ever opens a big supermarket in the middle of an island with 3 people on it. So we never get a true independent sample to test on.
Sure. Fascinating. Okay, so this has been an interesting conversation. I think it's given us the broad context in which we're going to drill into more details in some of the other podcasts that we do. Is there anything we should have been speaking about that gives us that broader context that we've missed?
The only thing I would, and I know we're going to talk about it later, is there's a lot of excitement around geospatial foundational models, which we are going to talk about in more detail, and you'll be talking to some of the guys who are building them for us. And I think when we talk about AI, I love the observation. I can't remember which psychologist it was who said there's no such thing as intelligence. There's multiple intelligences. So there's word intelligence, there's visual intelligence, there's musical intelligence, and there's spatial intelligence. And each of those intelligences need different formulations. And in the last 2 years, probably, I think a lot of people have woken up to geospatial intelligence. I know Google have done a lot of stuff with GeoAI and the population dynamics foundational model. So I think we are on the cusp of some really interesting new approaches using GFMs in tandem with other techniques.
Yeah, and just to kind of drill down on that point, when we talk about geospatial foundation models, we're talking about models that actually understand geography. We've spoken a lot about large language models and how they're fundamentally trained on the text that they've been given to read on the internet. Well, the text is text. When we talk about geography, we're talking fundamentally about maps. And all of those characteristics that maps have, your common or garden, ChatGPT doesn't understand yet.
No, can't. It really struggles. Like I say, where it's text, what's Camden like? It's pretty good. But if you say, how would I get from Camden to Shoreditch? Hasn't got a clue. Or why are certain why are certain roads busier than others? We've got no idea because it can't see the geographic syntax, which is what GFMs do. They understand this place is linked to this place. This place is not linked to this place. This place is like this place. So when you train the model on fundamental geography, you're going to get a geography reasoning thing. And that people are doing it, right? That, there's some really cool stuff going on.
Well, that sounds the perfect point to finish, giving us that look into the very near future where we're going to find much more about what geospatial foundation models are. Blair, thank you very much for your time.
Thank you.
Much appreciated. And for everyone watching and listening, thank you for giving us your time and look forward to the next episode.